All right, so in this video here, we're just going to have a look at how to actually use quotient law relative to some questions. Okay, the nice thing here, I've got a little text here. The derivative of a quotient is the derivative of the numerator, right? The numerator being f of x, times the denominator, g of x, minus the derivative of the denominator times the numerator all over the denominator squared. That is quotient rule in words, okay? Or you could see it as they've written it here, okay? So that's all we're going to do here is we're just going to take this and we're just going to plug in information. You got two functions. You got f of x up top and you've got g of x on the bottom. So you're going to derive the top, multiply it by the bottom, derive the bottom, multiply it by the top, and then divide by the bottom squared, the original bottom. Okay, so that's what we're going to do here, and then we're just going to clean it up and see what happens, right? So the derivative, f prime of x, is going to equal, you might have to label this one p of x or something, right? And g of x, right? But it's going to equal the derivative of p of x, right? So we're going to say 2 times 1 minus x minus, then we're going to say the derivative of g. Well, that's going to be negative 1 times 2x all over 1 minus x squared. Okay, and then we can do some expansion. Say, okay, well, 2 minus 2x plus, all of this is subtracted, sorry. It'll be plus 2x, right? All over 1 minus x squared. So we get the 2x's cancel, create a zero pair, and we are left with 2 over 1 minus x squared. Now, hopefully this looks familiar to you. You might think, oh, where have I seen this question before? All right, well, let's go take a look. Now I want you to keep track. 1, 2, 3 steps. Now let's go back up here. Is this or is this not the same question? Right? What a pain. Okay, first principles is, but very robust. It's very robust, right? In terms of its applicability. Right? That's what's great about first principles. You can apply first principles to any function f of x. It doesn't matter if there's a product of two functions or a quotient of two functions or a product of three functions. It doesn't matter. First principles is very robust because it's one method that works on all functions, right? What we're starting to do here is take first principles and be creative with it to come up with some laws and specific applications so that our life gets easier in terms of finding the derivative, right? It's keeping track of all this stuff for quotient rule, for product rule, for what we'll see this afternoon, right? But you can see, I'd prefer to do this all day long, as long as I knew the rule and I could use it, like apply it applicably, right? Like this is a lot of work to arrive at the same answer. But again, it will always work. Okay, it's like the quadratic equation. Do you want to use the quadratic equation? No, not necessarily, not unless you have to. But you could, it's the same thing here, right? Do you want to use first principles? No, because it's a lot of work. Will it always work? Yes, right? If you didn't know one of the laws or something like that and you needed to use it, okay? So that's that. We'll just do a few more examples then, right? So let's do this one now. So this is again like a p of x function, and this could be g of x, right? And let's see what happens. So f prime of x will equal the derivative of the top, 3, times the derivative of the bottom, oh sorry, not the derivative of the bottom, times the original bottom, x squared plus 5, minus, then we're going to derive the bottom, 2x, times the original top, 3x minus 4. And all of that needs to be divided by x squared plus 5. squared. The original squared. Okay, now let's just do some expansion. We're going to see 3x squared plus 15 minus, over here we're going to have 6x squared minus 8x, okay, all divided by x squared plus 5 squared. Okay, and then we can clean it up. So we're going to get negative 3x squared plus 8x and plus 15, all divided by x squared plus 5 squared. Okay, this is f prime of x. Okay, let's keep going. Much nicer to use in first principles. Look how fast we can do 4 questions, right? So here, just different notation. We want to find dy by dx. We're going to derive y with respect to x, right? What do we get? Well, the derivative of the top will be 0. That's going to be multiplied against x squared minus 4. And then we can say, okay, minus the derivative of the bottom, 2x, times the original top, 1. And that's going to be over x squared minus 4 squared. What do we get? Dy by dx will equal negative 2x over x squared minus 4. Okay? And that needs to be squared. One more. I would say with this one, I don't like the fact, like, we have basically, as it currently stands, we have product rule inside of quotient rule, or quotient rule inside of product rule, right? So I don't like that. So let's say we'll just get rid of the two binomials in the numerator by expansion, right? So we'll say 4x squared plus 2x minus 2x and then minus 1 over 2 plus x. Well, then we can, these create a 0 pair, and our new function here, just written differently, be 4x squared minus 1 over 2 plus x. Now, let's derive y with respect to x. Okay, well, in the top, we're going to see 8x, and that needs to be multiplied by 2 plus x, minus 4x squared minus 1 multiplied against 1, the derivative of the bottom. And all that needs to be divided by 2 plus x squared. Okay, and then we just do some expansion work and clean up like terms. Dy by dx is going to equal 16x plus 8x squared minus 4x squared plus 1, all over 2 plus x squared. Last part should be our final answer. We'll have, 8x squared minus 4x squared. That's going to equal 4x squared plus 16x plus 1 all over 2 plus x squared. Okay, that's it. Okay, I'll keep that one short so you guys can have a look at that. You can take that. You should be able to rip through some of these quotient law questions pretty quick. In the next video, we'll do some more questions on finding slopes of tangent lines, and then finding points where the tangent line will be horizontal. Okay, so we'll actually apply our derivative, find what it is, and then use that piece of information to answer other things. Okay, so that's the quotient rule in its application. Okay, just applying it to a few questions. You should have some homework questions to do on that as well. Okay, so I'll jump down to the last part and we'll have a separate video.